Hey there, everybody. Welcome back. This is chapter 15 in Anton's 11th edition Calculus Early Transcendentals book. This is College of the Sequoias, fall 2022. Chapter 15 is the wrap-up, the conclusion. It does everything, combines all of our multiple integrals, partial derivatives, vectors, all of that into some cool three-dimensional physics and stuff like that. Let's just jump into it. 15.1a, vector fields. So there's a lot of things in real life that we deal with that have vector fields, like the Earth, the gravitational field, all the forces inward towards the planet, and we have a vector field correlating for gravity. We could have a vector field for a river. So what a vector field does is at each point P, it provides a vector related to information there. So if we talked about in the river, the velocity of the water at a certain point, we could use vector fields for it. They generally, what they do is they provide an arrow to indicate direction and a length to indicate magnitude. So longer arrows mean stronger flow. As you'll see in some other videos that I've recommended, when sometimes these arrows just get so long that they do colors for the longer arrows to indicate strong arrow areas, but the arrows indicate which direction, like in this case, the velocity is going, or which way the water is moving. So as we see, as the water goes into a narrow channel, pressure has to go up, or velocity's got to go up because the pressure's constricted it down, but when it exits, it spreads back out, and so the water slows back down. This works in 3 space as well, like the Earth and stuff like that. Yeah, we're going to use forces F, where we have components in the I, J, and K direction. We will use vectors to indicate that, X, Y, Z. And we'll frequently denote F or F with a vector in it as just F. And I've got plenty of examples to show you that are related to real life. So let's just take a look at them. Close that. I've got, this is the Gulf Stream in the ocean currents, and I think the color is temperature, but you can see which way the water is flowing by the arrows. And so along the Gulf Stream, it flows from south to north along the Atlantic seaboard. And it gets stronger right along the coast. There's a strong, deep channel there, but there's lots of gyrations. Oceanography is a fascinating topic of study. I took a class on it in graduate school, and there's a lot of 3D vector calculus in it. Good stuff. Same can be said for airflow. This is a map of wind over the Americas at any given time. It obviously does change, wind changes, so the vectors change, but it's an example. This is an example from fluid dynamics of a turbulent field. Over here is a source of dye introduced into a water stream on the left, and the flow is to the right, and you can see how the dye is turned into these eddies by the turbulence in the water. And this is all able to be modeled mathematically. Good stuff using the stuff we're learning this chapter. Good old, like what I was showing in the river. Ways to do flows along a tube, but depending on the friction along the wall, the force or the velocity of the water in the center, how it's going. Particularly good one, our magnetosphere. So the solar winds from the sun, you can see the vectors, the long arrows pointing along them, the magnetic field, the properties of the magnetic field, which way the vector field is going. So you can see the magnetic field lines, good stuff. I have another, and then fluid rise. This is where there's something blooming up from the bottom. It looks very similar to the graduate school I worked on, where I studied the rise of magnetic flux tubes in the sun, and they rose to the surface. They had the same pressure as the surrounding plasma, but the properties of magnetism were different. which cause them to become buoyant and lift to the surface and become solar flares. So that was my graduate research in applied mathematics. It was really astrophysics under the name of applied mathematics, but it looked very similar to this. I'll pull out images and show you guys during lecture. That's it for this video. Peace.